Guys, welcome back to our video series of software engineering. So let's continue with the critical path method. So these are the steps involved in the critical path, method. The first thing to do is you identify your task, your specific task. Identify your task like requirement gathering, screen design, means form designs, report design, design your report, your output, design your database, you design, and so on. So you identify all these activities, and then you define the proper sequence of these activities, means the precedence, how they're following each other. You construct a network diagram, then you estimate time required for each activity. You determine the critical path, and then you update the critical path as the project progresses. So is what we have covered in the previous video. Now we are saying the critical path is a sequence of activity that represent the longest path through a project, which determine the shortest possible project duration. So is what I was telling you guys. So it's the longest path in terms of duration, the shortest project duration. And I told you that when you estimate, you add a margin. Now we have another example here, but this is augmented with more details, but not all of them interest us. So we have activity, we have start finish. We have the first activity here, which is A, B, C, and then D. We have 4 activities. And here we have the duration. Look at the legend here. The duration. So the duration of A is 5. The duration of C is 10. The duration of B is 5. The duration of D is 15. So what is the critical path? The critical path is ACD. Why? Because we move to C because 10 here is bigger than 5. 10 is bigger than 5. 10 is bigger than 5. So is why we move here. A, C, D. See this one. This is a critical path. We don't go here. So the duration of the project will be 5 plus 10, 15 plus this one, 30. The path, critical path you can see here is ACD. Good. That's the critical path. So this is the shortest, this is the longest path here on the graph, but the shortest time that our project is going to last. So if it is in terms of days, so our project will last a minimum of 30 days. Good. Now we have another notion, that you guys have to understand. We'll go back to that slide. The critical path represents the shortest times in which a project can be completed. In other words, any activity on the critical path that is delayed in completion delays the entire project. It means what? If an activity on the critical path takes longer, this is going to impact the duration of the project. You get that? Now, nodes not on the critical path, however, can be delayed for some amount of time without delaying the final completion of the project. node on the critical path contains the slack time. The slack time, which is also called the total float. The slack time, which is the total float. And this total float allows some flexibility in the scheduling. So how do you calculate the slack time? The slack time is the same with total float. It means the same thing. So you do the late start minus the early start. The late start minus the early start gives you the slack time. The CPM critical path is normally characterized by zero total float. So activities in the critical path, have a zero total float. It means they have a zero slack time. Let's come back here. What are we talking about here? We said that A, C, D represent the critical path. They represent the critical path. Now, this one has a duration of 5. This one has a duration of 10. This one has a duration of 5, and this one has a duration of 15. Now, here, what these represent, look at here, total float or slack time. We say that this is the total float or slack time. It is 0. It is 0. Why is it 0? It is 0 because we do 5 minus 5 is 0. 15 minus 15 is 0. 30 minus 30 is 0. 15 minus 10 is 5. Okay, this is still confusing. In a simple language, how are we going to explain this? Activities here will delay. Any activities, if A delays, it is going to delay the process. Why? Because this 5, the duration, this 5 is counted in the critical path. So it becomes 6. If this 5 becomes 6, so here we're going to get 31. Because we're going to do 6 plus 10 plus 15, which is 31. If 10 delays by 2 days, we're going to have 32, because we're going to have 5 plus 12 plus 15, this is 32. If D delays by 5 days, we are going to have 35. We are going to have 5 plus 20, which is 35. Why? Because it makes sense that activities in the critical path here, it makes sense that any delay happening in the critical path will delay the process, will add more days. So there is no flexibility here in the critical path. So duration of the critical path cannot have no flexibility. So they have no slack time. So it is why it's 0. Now to understand it, maybe this will help. Here, it is 5 days. Why? The slack time is 5 days. It means that, it's 5 days because, if we come here, this plus this plus this it gives 20, 25. 25. So we have 5 days. You see, we have 5 days, of flexibility. So we can delay up to 5 days. If we go beyond 5 days, then the project is going to be delayed. So the maximum flexibility here is 5. Why it is 5? Because when we count, if we include this in the critical path, like we have 5 plus 5 plus 15 is 20, 25. Now it is 25 because you see we have 5 days less compared to the critical path. So it means that this activity B can delay a maximum of 5 days. Otherwise, if it delays 6 days, we are going to have, 31 here. We are going to have 31 here, because we are going to have 11 here, because we do 5 plus 6, which is 11, plus this, which is 11, 16, plus the 16 plus 15, 30, 31. So here we have a slack time, a flexibility. So this B can still delay for a maximum of 5 days. If it goes beyond 5 days, so we have, a delay. Now, if we delay by 5 days, so here is 10. It's going to be 5 plus 10 plus 15 is going to be 30. It's still fine. But if it is 6, then there is a problem. It's going to. Now, this one is 0 then, because there is no flexibility. You cannot even add a single day without affecting the duration of the critical path. So it is why it is 0. You have 0 flexibility. It is 5 days, not more. It is 5 days, not more. It is 15 days, not more. It is 30 days, not more. You get that? Yeah. So it is, what we call slack time. So the slack time of the critical path is 0 because you have no flexibility. Now the slack time of the other path is not the critical path, is the difference, which is in this case 5. If you add 5 days here, it's going to be 30. If you add 6 days, then you are out of the flexibility. It's going to increase, up to 31, and that's the problem. So this is what we call slack time. Now we have another method that we call PERT. PERT borrows principle from critical path. So you use the same diagram, you use the same principle, but only that it includes, it adds another, other notion of optimistic, pessimistic, and realistic time. So we are going to explain that in the next video. So I hope you guys have enjoyed this video. So see you in the next video. Bye bye.